Hello and welcome. I am Vaibhav shah and our today's topic is engineering curves. We'll be learning how to draw parabola. So let us begin with the first example. Draw an isosceles triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by method of tangents. So we'll be learning how to draw parabola by tangent method here. So here we will be having one isosceles triangle. So let us first understand what do you mean by an isosceles triangle. So isosceles triangle means a triangle having two of its sides of equal length is known as your isosceles triangle. So let us construct first an isosceles triangle. So how to construct an isosceles triangle? So let us first draw one horizontal line of 100 mm long. Then after you should find out its midpoint, and then after from the midpoint you should construct one vertical line of 110 mm showing the height of that isosceles triangle, and after reaching to its top point you should draw one line on the left hand side touching the left hand side base point, and you should draw another line touching the right hand side base point like this, and you will be having this triangle ready. Then after let us give this triangle naming as A, B and C. Then after you should divide the line AC into 14 number of equal parts. So if you don't know how to divide any line into n number of equal parts or any number of equal parts, you should go and refer my previous lectures based on geometric constructions in order to get an idea how to divide any line into n number of equal parts. So let us in this case divide the line into 14 number of equal parts. Then after you should divide the line BC also into 14 number of equal parts. Then let us start giving numbering from a point A as a 0 in upward direction like this 0, 1, 2, 3, 4, 5, 6, 7 until you reach 14 number point at point C. Then you should start numbering from now point C first. So C as a 0 you should start numbering as 0, 1, 2, 3, 4, 5, 6 until you reach point number 14 at your point B. Then after it is very easy, we should connect the similar points. So let us join point 1 with point 1, point 2 with 2, 3 with 3, 4 with 4, 5 with 5, 6 with 6, 7 with 7, 8 with 8, 9 with 9, 10 with 10, 11 with 11, 12 with 12, 13 with 13 and 14 with 14. So we know that here one curve is generated which looks like what? Parabola, right? So we should now paste this curve by a darker line in order to have the accurate parabola drawn. So let us draw on dark line and we should be having parabola ready. So by drawing this dark line we are having this parabola ready. But here remember that the axis of parabola is what? 55 mm. So if you try to measure the axis of parabola it would be a 55 mm. So let us see, the axis of parabola is what? 55 mm, but we were having the axis of isosceles triangle what? 110 mm. So always remember, when we double the axis of your parabola, we will be having the axis of this isosceles triangle. So whenever you are using this tangent method, you should construct the isosceles triangle in such a way that the axis of the isosceles triangle must be double the axis of your parabola. Right? So now let us move to a next example. So we'll be having problem number 2. A ball thrown in the air attains 100 meter height and covers horizontal distance of 150 meter on ground. Draw a path of the ball. So here is a practical example. You are on the ground and you are throwing a ball which attains certain height and certain distance. So which kind of curve is generated? Right, so it is your parabolic trajectory generated. So here we should draw a parabola. So here we will be using one method which is known as a rectangle method in order to draw a parabola. This method is also known as an oblong method to draw a parabola. So rectangle method or an oblong method to draw your parabola. So we should construct one rectangle with the length equal to the total horizontal distance covered by the ball and height is equal to total height attained by the ball. We should construct the length of this rectangle as 150 meter or you can say 150 mm and height is equal to 100 meter or you can say 100 mm in our case. After constructing the rectangle, we should divide this rectangle into two halves by constructing the vertical line from the midpoint of the length. Now let us start the procedure. So we would be dividing the vertical line into some equal number of equal parts. So now here we will be dividing this vertical line into 6 number of equal parts like this: 1, 2, 3, 4, 5, and 6th number point would be the final point, corner point. Then after, if you are dividing this vertical line into 6 number of equal parts, that means that you should compulsorily divide the horizontal line also into 6 number of equal parts. 1, 2, 3, 4, 5, and 6 point would be the intersection of vertical and horizontal line. Then after, let us give the numbering to this point, starting from the corner point as 0. 1, 2, 3, 4, 5, and 6 point would be the top point. Therefore, let us start numbering from, once again, corner point at 0. So 1, 2, 3, 4, 5, and 6. Therefore, what we should do, so we should connect this point 1 with the top point of this vertical line, 2 with that point, 3 with the top point, 4 with the top point, and 5 with the top point. And 6 point is already connected with the top point. So that top point is nothing but the vertex of your parabola. What we should do, we should follow the similar procedure on the right hand side half. So we should divide this vertical portion into 6 number of equal parts. Then after, we should divide the horizontal portion into 6 number of equal parts. Then after, let us follow the similar procedure. So let us connect the points from 1 to the top point, 2 with the top point, 3, 4, 5, and 6 is already connected. Then let's draw the vertical lines from each and every point. So we'll be drawing the vertical lines like this. So we'll be having this vertical line drawing like this. Then after, what we should do, so we should identify the intersection point by this inclined line and the vertical line. So let us highlight this intersection point by a dark point like this. So we should define each and every point in order to easily trace the curve. After getting these points, you should join this point by a smooth line. Either you can use a freehand drawing or you can use it a French curve. So let us join these curves. This is nothing but a required parabola. So whenever you are throwing the ball, it will attain that height and it will reach to that distance. So it will trace out which curve, a parabola, right? So let us move ahead and let us see one more example. So construct a parabola enclosed in a parallelogram of 100 mm and 80 mm having conjugate angle of 65 degrees. Use the parallelogram method to construct a parabola. So this is a method, as we have seen previously, it was our rectangle method. Now we are constructing the parabola by a parallelogram method. So it is the same method as we have seen in our ellipse. So we should be constructing this parallelogram. So we know that parallelogram means object and opposite sides parallel to each other. So we have constructed the parallelogram, but remember, in parallelogram, the vertical and horizontal heights are not the axis of parabola. These are just the means to draw your parallelogram. So here we should construct the horizontal line and then we should construct this inclined line at what, 65 degrees. Because it is said that conjugate angle of axis is what, 65 degrees. We should draw a horizontal line and then after we should draw an inclined line at 80 mm and this 80 mm line would be at 65 degrees as you can see in figure. Then after, what we should do, let us give the naming. So we will be giving this horizontal line as AD name. Then you should find the midpoint of that horizontal line and you should define the point C as you can see. And then after, from point C you should draw one parallel line inclined at the same angle 65 degrees and you will be having point D at the top. So point D would be nothing but your vertex, right? So now then after, what we should do, we should divide the inclined line into some equal number of equal parts. So we'll be dividing the inclined line into 6 number of equal parts, starting from point A as a 0, then 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash would be a point E itself. Similarly, we should divide this line also into 6 parts, starting from your point 0. So 0, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash would be your point F itself. Then after, we should divide the horizontal line of AC into same 6 number of equal parts, starting from A as a 0. 1, 2, 3, 4, 5, 6. 6 would be a point C itself. Then after, we should also divide this portion into 6 parts and we'll be having point like that 1, 2, 3, 4, 5, 6. Then after, what we should do? Simple. We should connect point 1 dash with your point D, 2 dash with D, 3 dash with D, 4 dash with D, 5 dash with D, and point E is already connected with D. Similarly, we should connect point 1 dash with D, 2 dash with D, 3 dash with D, 4 dash with D, 5 dash with D, like this. Then after, it is very easy, we should be drawing one line from your point 1, which must be parallel to your line AE. You should use your roller scale or drafter. You should put your drafter roller scale onto the line AE and you should draw one line line passing from your point 1, which would be inclined line, and which should intersect your line 1, and it will give you point P1. Then after you should draw one line from point 2 in order to get your point P2. Then after P3, P4, P5, and then after you can use the similar methods. You will use the drafter or roller scale. You should put your drafter or roller scale parallel with this line, and you should generate the parallel lines, and you will be having your points P1 till P5 onto the lines. After getting these points, simply you should connect this point and join these points, and you will be having one curve generated, which is nothing but your parabola generated by a parallelogram method. It is the same method as we have seen in the rectangle method, but the difference is that we are having the 90 degree in the rectangle, it's a horizontal and vertical line, but in the case of parallelogram, we are having the 65 degrees between your horizontal as well as inclined lines. Very easy. So let us see next example, problem number 4. Point F is 50 mm from vertical straight line AB. Draw the locus of point P, moving in a plane such that it always remains equidistant from point F and line AB. So it seems like a definition, right? So you should remember the definition of parabola, and the definition of parabola says the same. So it is nothing but showing that the example is based on what? A parabola. So we will be drawing a parabola from this example. So let us start the example. So here we are having the focal and the vertical straight line AB, that means the directrix. So we are talking about the focus and directrix. So that's why this method is known as your directrix focus method. And we will be generating the parabola by directrix focus method. So let us first construct one vertical line, which is nothing but what? AB, and which is your fixed vertical line, and is known as your directrix. Then you should draw one horizontal line from any arbitrary point, and you should call this line as your axis. On this axis line, you should define your focal point like this. So this is your focal point. So right. So now focal point F is 50 mm away from your vertical straight line. So we have taken 50 mm distance in order to find out a focal point F onto the straight line. Now we know that eccentricity of parabola is what? 1. That means your vertex is at equal distance from focus as well as your directrix. So we should find out the midpoint of this line of a focal line. So we will be having one point, which is nothing but what? It is your vertex. Now after getting your vertex, what we should do? We should take any random 4 points at any distance. So let us take 4 random points. We have taken the 4 random points. Then after, what we should do? So we should draw vertical lines from each and every point. Then after, let us take out our rounder. Let us put our rounder at O and take the distance as O1 on your rounder. Then after, put your rounder at focal point F and try to cut this one line like this above and below. So we will be having these 2 points P1 and P1. Now then after, let us take the distance of O2 onto your rounder. Let us put your rounder once again onto your focal point F, and let us try to cut the vertical line of O2. You will be having the point like this. So it will give you point P2, P2. Then after, you should take O3 onto your rounder. Put your rounder at focal point F and try to cut your line 3 like this above and below. So you will be having these 2 points as your P3 points. And then after, finally you should take on your rounder O4 distance. You should put your rounder at focal point and let us cut your 4 line like this. So you will be having this final point as P4, P4. So you should identify this point as P1, P2, P3, P4 in upward direction as well as P1, P2, P3, P4 in downward direction also. So you will be having these points. After getting these points, finally you should simply connect these points by a smooth curve, and this will give you a curve which is nothing but what? Your parabola. So very easy. So this method is known as your directrix focus method, or you can say it is general method. So now let us move ahead. Define this curve. So we will be defining this curve as parabola. So now finally, to draw tangent and normal to the curve from a given point Q. So we will be now drawing tangent and normal to the given curve. So let us take one parabola ready-made available. So we have taken the parabola from directrix focus method, and we will be trying to draw a tangent and normal to this parabola. So what we should do? We should first define any random point Q where we need to draw a tangent and normal. So let us define point Q somewhere there. Then after, you should connect your line of Q with your focal point F. After constructing this line, you should make 90 degree angle with this line QF, and it will be intersecting your directrix somewhere there. So after getting your point, intersection point on your directrix, you should connect this intersection point with your point Q what you should do, you should draw one perpendicular line passing from the point Q to this tangent line in order to get your normal ready. So this is nothing but your tangent normal in the case of parabola. Very easy. So this is the same method as we have used in ellipse also. So whenever you are having directrix focus method, you can use this method whether it is ellipse, hyperbola or parabola. So now let us see one more method. See, if suppose you have drawn your parabola with the help of your rectangle method, then how to draw a tangent and normal? Let us suppose if we need to draw tangent at this point S dash on your parabola as highlighted. So you should draw one horizontal line until you reach the vertical vertex line of your parabola like this. So this line you will be having your point R. After defining your point R, take the dimension of VR and draw and extend this line VR above direction. You should reproduce the dimension of VR in above direction. You will be having point T dash. After having your T dash point, you should draw one line from T dash passing from your S dash, and you will be having one line generated which will give you a tangent T dash. Thereafter, we should simply draw a 90-degree line to this tangent line in order to get your normal ready, which is nothing but what? N dash. So it is very easy. You are just reproducing the dimension of VR and on the opposite side of your vertex, and you will be having your tangent and normal ready. So whenever you are having your parabola drawn by a rectangle method or by a parallelogram method, you can use this method. So that is all from my side. If you have enjoyed my content and teaching side, do not forget to like, share and subscribe to my channel. If you have any doubts, any queries, feel free and comment down below. Keep learning, stay connected. Bye bye.